This is solution for question 5 homework 1. In the question, we are given that there are some 100 people who are waiting for the results of the blood test for some rare disease. The probability for a person having the disease is 0.1. Here we have two methods of getting this done. So method 1 is test each person one by one, which requires 100 blood tests. So method 2 is we divide 100 people into 10 groups with 10 people in each group. Then mix the 10 people's blood and test that mixture. If the mixture is negative, that is there's no disease, then no additional tests have to be done. And if the result for the group is positive, then each person in the group has to be tested individually. So we are asked to find the average number of tests we need to do using this method. This is a classical method of group testing, which has been used historically during World War II as well. So let us say that the minimum number of tests required is 10, because even if no person has the disease, we still have to do 10 tests because there are 10 groups. So let us denote y as the total number of tests required and x as the total of the number of tests per group. You can represent y as 10 plus 10x, where this 10 is the number of groups. So a more rigorous representation would be something like y equal to 10 plus sigma I equal to 1 to 10 xi, where xi is each group, and xi can take a value of 10 with a probability p0, and can take a value 0 with it can take the value of 10 with probability p1 and 0 with a probability p0. So p1 is if at least one person in the group has the disease, and p0 if no person in the group has the disease. As we have discussed earlier, if at least one person in the group has a disease, we have to do 10 tests, that is test on each person individually. And if no person in the group has a disease, no additional tests have to be done. So the probability of at least one person having the disease is p1, and no one having the disease is p0. p0 is 1 minus 0.1. 0.1 is because the probability of having the disease is 0.1, therefore not having the disease is 1 minus 0.1. So 1 minus 0.1 whole power 10, since there are 10 people per group, which is 0.1 whole power 10. And probability that at least one person in the group having the disease is p1, which is 1 minus 0.9 whole power 10. Over here x can be denoted as a random variable, therefore the average value or the expected value of y is the expected value of 10 plus 10x. Since 10 is a constant and the average is a linear operation, we can calculate it as 10 plus 10 times the expected value of x. So the definition of expected value of x is sigma expected value of x equal to sigma xi times p of xi, where I is all the possible values. So the expected value is 10 plus 10 times probability of p0, which is probability of no one in the group having the disease, times 0.9 times 0 plus 10 times p1, which is at least one person in the group having the disease. So substituting the values and doing the calculation, we get number 75. So the average number of tests required using method 2 is 75, which is better than method 1, which requires 100 tests.